Good morning everyone. This video is about a flue gas and Orsat apparatus is the technique that explains how a mixture which contains a moisture is getting separated and useful for the further industrial application as a inert gas from flue gas. So what is meant by flue gas? It is a gaseous byproduct of combustible process which in turn contains various components such as oxygen, carbon dioxide, carbon monoxide, sulfur, water vapors, nitrogen oxides, etc. So these are all the impurities that present in the flue gas. It is a byproduct material that obtained from the exhaust of those um, completed chemical reactions, or we can tell after the reactions the gas is going out, some of the gases. So some of the impurities present in those gases is called flue gas. So from those impurities is getting absorbed or separated. Okay, that's the aim of Orsat apparatus. So Orsat apparatus is a laboratory equipment which is a versatile one, a very old technique, and it looks simple apparatus to analyze how much it has oxygen, carbon monoxide, carbon dioxide content, etc., and how it is getting separated from those and getting inert gas in a pure form. So this is the setup of Orsat apparatus. Here we can see 3 towers which contains KOH, pyrogallic acids, cuprous chloride, etc. Initially, a mixture with those impurities, a flue gas is applied to the tube which has a fused calcium chloride. So calcium chloride role is to absorb the initial moisture that present in the material. After that, it is subjected to pass through KOH, pyrogallic acid, cuprous chloride, etc. So 3-way stopcock is there to allow the flue gas to pass through and getting reacted with those 3 materials that in the tower. When it is subjected to react with material of tower 1, 2 and 3 towers are should be shut it, since not to involve in this reaction. So initially it is allowed to react with KOH, which in turn it absorbs a carbon dioxide. After that, it is passed through the vent and allowed to react with gas burette, which has a water there, and it would be testing that how much value it has through the burette readings. Initially, it should be testing before it is subjected to carbon dioxide absorption. It has some value in the gas burette. After it get absorbed, there will be a changes in those value that we can see in the marked of burette. The meniscus changes will be there. After that, KOH absorption of CO2 is done, it is allowed to pass through pyrogallic acid. It is a phenol type material which in turn pyrogallic acid absorbs oxygen. After that again it passed through those gas burette and tested the how much material to through that meniscus value it is getting absorbed, okay, in the second tower. Okay, and finally after that remaining material is subjected to react with cuprous chloride. If there is CO, it will absorb, and again finally it pass through the gas burette and tested how much the gas is. The reduction of those gas denotes the absorption of CO2, O2 and CO, etc. This is the simple method of testing how much the pollutant is getting absorbed. So working mechanism. It contains a horizontal tube at one end of this tube having a CaCl2 is connected to 3-way stopcock. Other end has to graduate burette. Stopcock of bulb 1 is having KOH. Flue gas passed and CO2 is absorbed by KOH. Decrease in volume of flue gas indicates the volume of CO2. Similarly, stopcock of bulb 2, pyrogallol material which absorbs O2. Decrease in volume of flue gas here indicates the volume of O2 that can be absorbed. Stopcock of bulb 3 next to final, which is having cuprous chloride, CO is absorbed by cuprous chloride. Decrease in volume of gas indicates the volume of CO. Application of flue gas analysis. It gives idea about a complete or incomplete combustion process. If flue gas contains CO, it indicates incomplete combustion. If it is oxygen, it indicates a complete combustion, and excess supply of oxygen is there. So thank you so much for listening.